I'm going to present you my presentation entitled Unlocking Soil Organic Carbon, Importance and Assessment Methods. So this was a part of my thesis, which were supervised by the team that you see below, and in collaboration with LRI and CIRAT. So, about my background, Cedric talked about it earlier. I've done my undergraduate studies in ESA at Antananarivo University. I was specialized in tropical agriculture and sustainable development. Then I've done also my MSc and agronomist and engineering, also in ESA. And I've specialized in soil biofunctioning and environment. Then I've done my PhD, which was focused on soil organic carbon and soil nutrients in forest and agroforest plantation, mainly in smallholder plantation. In between, I've done mobility semester in 2019 at UniLaSalle, where I've studied about agronomy and territory, mainly about chain value analysis, and I've done also research internship in last year. So it was last year at Montpellier, and I was studying more focused on soil organic carbon estimation by calibration transfer. So mainly my area of expertise is mainly about carbon and all agriculture related in carbon, mainly about forest plantation, modelization of soil carbon, soil nutrients, soil analysis, which were related to food security, climate change, and carbon storage. I will also say talked about eucalyptus here because I've studied mainly that species in my thesis. So the plan of this presentation is I'm going first to talk about the soil, then after I will talk about why soil organic carbon, then after we will talk about how to measure it and any outlook and the key takeaways. So first the question, why do we study soil? Do you have any ideas why do we study soil mainly? You can participate if you want. Afaka miteny gasy raha ohatra hoe misy manana hevitra ve fa manino tsika mianatra momba ny sol tany. Tsisy hevitra. Okay. Okay, so we study soil. First and foremost, we have to think about the soil is not just dirt as we think. It is a complex living system, and we know soil as the skin of the earth. So it takes, just for information, it takes more than to form 1 centimeter of topsoil, it takes like 100 to 400 years to form just 1 centimeter, depending on climate and many parameters. So it provides many services. The soil provides many services, including ensuring food security, because we know that soil supports agriculture, forestry, and agriculture with a big A, and provide nutrients for the plants and ensure also, by the way, plant growth. It concerns also water retention. It parameters that the soil parameters water retention. We can also talk about climate regulation with the soil because soil stocks carbon and the respiration of the soil and the biodiversity in soil affects the carbon in the atmosphere. But also soil permits to remove contaminants in water. It is a natural filter and ensure water quality. Also, water management, as I said earlier about water retention, that is related to food security, and about biodiversity. Soil content an important biodiversity, as just so you know, the number of living organisms in just 1 teaspoon of soil or fertile soil is like 9 billion of living organisms. So that's about the soil. We're gonna focus, so we can say that it is the foundation of life, and here we're gonna focus more on about food security and the climate regulation. Here, and then after that, we will talk about why soil organic carbon. Why do we study soil organic carbon? First, what is soil organic carbon? To know that, we have here the soil components, different soil components. So, the soil component is composed, the half of it is composed by air and water. Air is generally O2, CO2, CH4, and here the half of it, almost of it, is composed by mineral particles, sand, silt, and clay, and just the 5% is composed by organic matter, and that organic matter is subdivided in 3 parts. There are the organisms, so we have earthworms, nematodes, fungi, what else? Bacteria. We also have the roots for the 10%, the roots of different plants, and then 80% is composed by humus. And soil organic carbon is in every part of these 3 components of organic matter, and it represents more than half of the organic matter. So the organic matter is the umbrella term, and the soil organic carbon is the main part of it. Here is the carbon cycle, just to explain why we talk about soil and carbon. So as we know, I will begin here with the photosynthesis phenomenon. With the photosynthesis, we have the plant capture CO2 and form organic carbon, and it is by that organic carbon that enter in the soil, and after that the carbon in the plant is transferred in the soil, but after that by the respiration of different dead organisms and waste products, we have the respiration, and the carbon is transferred after that in the atmosphere. So that's the cycle of the carbon where the soil enter, and so why we study soil? To answer that question, the soil is the main terrestrial carbon sink, which represents 2,500 gigatons of carbon, and that is more than 4 times of biotic pool, and more than 3 times of the carbon in the atmospheric pool. That carbon sink is divided in two different types of carbon. We have the soil organic carbon and the soil inorganic carbon, and mainly so we have the soil organic carbon with that quantity, and that is the soak. The soil organic carbon is the soil is a soil health indicator. It is the main pool of soil nutrient storage. So this is, we call this the clay-humic complex. That ensure, in fact, the exchange between the solution of soil and the organic matter in the soil. So the plant is just here, for example, and the roots are here to take the nutrients in the soil, solution of soil. And so the structure of the soil and the components of the soil ensure the fact that the plants have all the nutrients that they need to ensure their growth. So that's why I talk here about the soil affects soil structure, water infiltration, and plant growth. As we see here, for example, also, we have the difference between soil compaction. We have here a good soil structure where water can enter in different zone, different area, and the root can grow. That is the ideal. And but here the root is really the growth of the root is not very good because of the structure of the soil, and that is related to the soil organic carbon. So so as we know, we can affect the sector that we call, we have the sector that we call AFOLU, which is agriculture, forestry, and other land use. So that sector permits all the global people to ensure food security, but also is responsible of 22% of global GHG emissions. Land use change, we can see that land use change is a major and the main driver of soil organic carbon at global scale. It plays a crucial role in regulating soil organic carbon dynamics and GHG emissions. Depends on the direction of the land use and land management practice. This action can increase or decrease the soil organic carbon. As we see in this slide, we can see that that shows the variation of the percentage of change in soil organic carbon due to the land use change. So we see, for example, a grassland here, to forest land. We see that we have that grassland to forest land. We see that there are an increase of 1%, more than 1%, just 1% of the soil organic carbon. That is not significant as we see here, but the change to from cropland to forest land, for example, permit to increase soil organic carbon by more than 50%. For example, also here we have cropland, even just cropland to grassland permits to increase soil organic carbon by 26%. So, as we can see, when we change forest land to no matter what land use, we can see that it always decreases, because forest land, we know that forest is really the best land use that can we can have soil organic carbon in the soil. Okay. So the change of soil organic carbon depends on the previous land uses, as we see earlier. It also depends on different tree species, and the tree species that we choose, because it varies really the root and the carbon that the tree transfer to the soil depends on their species, on their growth. It also depends on soil properties because, for example, we have a soil that is more clayey, that can conserve more carbon than soil that are more sandy, that have more sand. And it also depends on climate because, for example, we do not have the soil organic carbon the same with the same land use in the temperate zone compared to the tropical zone because we have different kind of respiration, different biodiversity in the soil and everything. It also depends on the crop or forest management, the fact that we do everything that we do with the soil, like how is it? Labour, je sais pas. And the plantation age. But the impact of soil organic carbon, we can see that in the food security, as I talked about earlier. It can increase yield because we have more plant growth. It can also help us to mitigate climate change because it permits us to sequester carbon in the soil, and we can improve the income of the smallholder farmers by carbon credits, and it already works in Madagascar nowadays, even if the price is not very good until now. Then to do that, we have to know how do we measure soil organic carbon. So to do the assessment, so in there, I will give you a case study of tree plantations and agroforestry systems that I've done in Arivumamu, Région Itas. I will explain my experimental design, my soil sampling methods, and the soil organic measurements that we have done. So to begin, we have worked in the study area of Arivumamu in Forfuktani. We have a mean temperature that is not very hot. We have worked with feral soil, which is characterized by a really low, this is a very poor soil because it have low nutrients. We can see here the color of the soil, it is very red. It means that it does not have much carbon, because carbon is more like, soil rich in carbon is more black than red. Then concerning the experimental design, we have tested the land use change from pseudo-steppe, that is known more as the grassland, which are plot of that we see everywhere, poace. We compared that after 2-year-old with different land use. First of all, we have tree plantation composed by Corymbia maculata and Acacia major, which are fast-growing trees that are cultivated in Arivumamu. We use mainly in wood energy because I've worked with a project focusing on wood energy. Then after that, we have also compared that land use with cassava monocrop. Cassava, which is an important crop. Also, an agroforestry systems with cassava. So with the same tree that you use here, we introduce cassava in there. We compared also with Bambara groundnut, which is legumes crop, and agroforestry systems with Bambara groundnut. So, and we have 3 replicates also that are different pictures of acacia majum and agroforestry system with cassava. We have here the summary of the different tested land. So we have pseudo steppe, cassava, bambara groundnut. We have like nine different types of treatments that we repeated 3 times. And before talking about the soil sampling part, I just want to say that we have 2 different types of soil organic carbon measurements that we use. We have soil organic carbon content and the soil organic carbon stocks. So the carbon credit and everything that you measure is mainly about the stocks, not about the content. So we have to do the calculation of the stocks based on that formula. So we have to take the soil organic carbon content here and the bulk density of the soil, and we have done that with 6 layers of the soil from 0 to 100 centimeter. And about the soil sampling in the tree plantation and the agroforestry systems, we have done take different types of soil sampling. So with that is, for example, here we have done soil sampling here and here also. That is the figure. And here is the soil sampling position for bulk density. We have done that in the middle, and we use the same bulk density for that plots. So we have like 3 pseudo-replicates, 4 pseudo-replicates in the entire plot to have a representativeness of all the plots. And for the plots that we call control, that does not have any trees, we have done just a triangular equidistant device. We have done 3 sampling positions that we have taken, and 1 for the bulk density. So that are some pictures that we have taken during the soil sampling. That is the way to do the sampling of the soil for each point. So because it is very difficult to do it manually, we had to do it mechanically. So that is the way to do it. And for the bulk density, we had to drag soil at 1 meter here. Then after that, after the soil sampling, the soil measurements, I want to talk about the different soil organic carbon measurements. We have the traditional conventional method that is well known, the dry combustion of Dumas, which use an oven of 900 degrees. That is not very, that is more conventional than traditional, but we use mainly the wall clay black methods, which is the wet oxidation, which is more less expensive than using that oven. But those methods are more accurate, but still expensive even with the wall clay and black. But we have some emerging method that we use spectrometry, which is less expensive than the conventional method, and permit us to obtain faster acquisition of soil quantitative data. So we use those materials. We have different materials to do that. And that's what I have done during my research internship last year, and we focused on that use of spectrometry on soil organic carbon. So it consists mainly about spectral analysis and spectral acquisition of the soil. So I focused on the mid-infrared area. We have all of that, and we have the infrared part, and we focused on just from 4,000 to 200 centimeter per centimeter. After the spectral analysis, we do some model calibration. After that, we use few measured samples for validation, and we do the prediction of carbon organic content after that. So that is the result of spectral analysis acquisition. So that is the soil of Madagascar, feral soil, that we analyzed with spectrometer of mid-infrared spectrometer. So where is the carbon here? The carbon is that peak that we measure, that is the CO2, and we measure that. And also there is also that bond here that we also need for the measurement of soil organic carbon. After doing that spectral analysis, we have done the modelization. We have done the partial least square regression to do the modelization. We compare different types of method, local, global, with using logarithm of SOC or just SOC. We have also done prejudgment, which erase noise spectra, but I will not really talk about that here. Then after that, we have that there's models that we think I did have a very great models in my thesis. We compare different criterion, those criterion, and here, for example, we have a very accurate models for using spectrometry. So we can see that here we have just an error of 3.6 gram per kilogram of soil, gram of carbon per kilogram of soil, and a bias of less than 1%. So to finish this presentation, some key takeaways. The soil organic carbon is a foundational component of healthy ecosystem. It is a multi-phased value. It is vital for climate, food, and biodiversity. And also, there are recent tools to assess soil organic carbon that are more less expensive and more, we can say that very accurate based on my results. And I want also to emphasize the role of land use change in the soil organic carbon storage or sequestration. So that's all that I have to present. Thank you very much for your attention. Thank you. If you have any question, you can ask in the comments.